Hello everyone, my name is Vicitra anak perempuan Segarang and my metric number is 198839. So in this video, I'm going to show my solution on one of the question that given by our lecturer. So the question given is we need to solve the given Cauchy-Euler equation by using substitution x equal to exponent of z followed by method of inverse operator 1 over linear differential operator, and then with the equation given is x square y double prime plus 4xy prime equal to 12x square plus 4y. So the first step is we need to transform the equation given into the Cauchy-Euler equation. So the general form of Cauchy-Euler equation is in this form, where the a naught a1 an minus 1 is actually the constant, and then the right side is x, where the function of x. So from the equation given, so we transform it into the form of Cauchy-Euler equation. So we just move everything that consists of x and y term together, or x and y term only into the left side, and only leave the function of x, where is x into the right side. So here we move 4y into the left side, so it will become x square y double prime plus 4xy prime minus here plus 4y, move to the left side, become minus 4y equal to 12x square. So here our x is 12x square. This is our x. And then move to the second step is we need to use the substitution into the Cauchy-Euler equation. So the substitution is we let x equal to exponent of z. So noted that from the lecture note, so we can find the y prime and y double prime using this general formula. So this general formula already proved in the lecture note. So here is the y, and then n power of n here is the order of derivative equal to e minus nz d minus 1 d minus 2 until the d and minus n plus 1y. So here we can find the y prime and y double prime using this general formula. So here we get our y prime is equal to e, and here is 1, so e power of minus z, and then dy. And then our y double prime become e power of minus n is 2, so minus e power of minus 2z d time with d minus 1 y. So here we get our y prime and y double prime. So next step, if we just substitute x, y double prime and y double prime into the Cauchy-Euler equation, so we get x square. So x square is x is e exponent of z, so we get e z square time with y double prime. Our y double prime is e minus 2z d minus 1 y, and then plus 4x, our x is e z, and then y prime is e minus z, e power of minus z dy minus 4y equal to 12, and then 12x square, our x is e z square, and then we simplify this equation as simplest as we can. So e 2z, here we get minus 2z d minus 1 y plus 4ez minus z dy minus 4y equal to 12e to z, and then here noted that e exponent of 2z minus 2z, so it will become exponent of 0 where is equal to 1, and here also become exponent of 0 equal to 1. So we solve it, so we will get d minus 1y plus 4 dy minus 4y equal to 12e to z, and then further simplify it, d square minus dy plus 4 dy minus 4y equal to 12e to z. Further simplify, d square y minus dy plus 4 dy minus 4y equal to 12e to e to z. And then this one minus dy plus 4 dy, so we get plus 3 dy. So d square y plus 3 dy minus 4y equal to 12e to z. And then here we can factor out the y, and so we get d square plus 3d minus 4y equal to 12e exponent of 2z. So here we get the final form of our equation. And then from this, so the next step, if we need to find the auxiliary, solve the auxiliary equation and find the root, so we can find the yc. So here from previous equation, so we solve the auxiliary equation. So our equation just now is d square plus 3d minus 4y equal to 12e power of 2z. So we take this part and then solve it auxiliary equation, find the root and get the root. So we get d square plus 3d minus 4 equal to 0, so we just let d equal to m, so m square plus 3m minus 4 equal to 0, and then we factor this to find the root, or other is we can use the equation to find the root. So we get m minus 1 m plus 4 equal to 0. So check it, so m square plus 4 minus 1 4 get okay. So here we get our root is equal to 1 and minus 4, and then so our yc become c1e power of x plus c2e power of minus 4x. So this is our yc. So the next step is we need to find our yp. So noted that from the question is followed by method of inverse operator. So obviously that we need to find the yp using the inverse operator method. So here recall back the inverse operator method. So here is actually the inverse operator method consists of two cases. So the first case is we apply this if the LA is not equal to 0, and for the second case we will use this formula if our LA is equal to 0 and our MA is not equal to 0. So the first thing first is from the equation we need to determine our A, our LA and our LD. So here from the equation, so our A is we get from the power of exponent. So here noted that our A is equal to 2, and then our LA is this part. So our LD is d square plus 3d minus 4. A is equal to 2 and our LD is d square plus 3d minus 4. Then the first step to determine whether we need to use case 1 or case 2, so we need to find our LA. So we just substitute D with A. So our LA, where our A is 2, so our L2 is equal to, just substitute D with 2, so 2 power of 2 plus 3 times 2 minus 4. Here we will get 4 plus 6 minus 4, we will get 6. So since our LA is equal to 6 where it's not equal to 0, so we need to proceed with the case 2. We need to proceed with the case 1. So we just use this formula to solve and find for our YP. Because our LA is not equal to 0, so we proceed with case 1. So the case 1, so our YP will be equal to 1 over LD and then EAX, where our LD is D square plus 3D minus 4, and then actually this side is we need to time with our arc. So we need to include the 12 here. So we time with 12 E to Z. And then noted that from it already proved that our LD is actually equal to LA. So here we need our LD, so we substitute LD with LA. So we just substitute D with A, where our A is 2. So it will equal to 12E exponent of 2Z equal to, we substitute D with 2, so 2 power of 2 plus 3, 2 minus 4. So we already calculate here our LA is equal to 6. So 12E exponent of 2Z over by 6. So 12 divided by 6 become 2E 2Z. So here we get our YP is actually equal to 2 exponent of 2Z. So for the final solution, so we just plus our YC with YP. So our solution is Y equal to YC plus YP, where our YC is C1. YC is C1 exponent of X plus C2 exponent of minus 4X, and then plus our YP is 2 exponent of 2Z. So here, and then noted here that just now we use the substitution where X equal to exponent Z. So we need to substitute back our exponent Z equal to X. So our final solution, so since that X equal to exponent Z, so our Y equal to C1 EX plus C2 E minus 4X plus 2, and then here is actually EZ power of 2. So we substitute back, exponent of Z is X. So we will get C1 exponent of X plus C2 exponent of minus 4X plus 2X square. So here we get our final answer, where is Y equal to C1 exponent of X plus C2 exponent of minus 4X plus 2X square. So that's all from me. Thank you.